The Pythagoras theorem was founded by a Greek philosopher named Pythagoras, and he researched and found that in a right triangle, the square of the hypotenuse is equal to the sum of squares of the other two sides. In fact, the Egyptians had already made use of the Pythagoras theorem in the construction of the pyramids. As you can see in the figure, there's a situation of a right angle triangle. So what is the Pythagoras theorem? If you look at this triangle, you'll see A and B as the length of the perpendicular and base of the triangle respectively, and C is the length of the hypotenuse. So we're trying to say that A square plus B square is equal to C square, or the square of the hypotenuse is equal to sum of squares of its other two sides in a right angle triangle. Now you can always ask me an important question: how do we prove the Pythagoras theorem? Well, there are many proofs available, but I'll just show you a simple one in the next slide. Now we're going to prove this through this square. There's a large square whose side is A plus B, and inside it there's also a small square whose side is C. So the area of the large square is A plus B whole square. Area of small square is C square, and if you can see, there are also four triangles formed by the inner square with the base A and height B, or in all the cases. And you can see that the area of four triangles will therefore be 4 times half base into height, which is 4 times half A into B. Now, area of the large square is actually made up of the small square and the four triangles. So we can see that if we just plug in all the values from the ones that we've just listed, A plus B whole square is C square plus 2AB. And now on the left hand side, if we use the expansion for A plus B whole square, we get A square plus B square plus 2AB, and that would be equal to C square plus 2AB. And on cancelling 2AB from both sides, we are left with A square plus B square equal to C square. Let us now look at a simple example where we've again taken a right angle triangle ABC, right angled at B. AB is 5 centimeters, BC is 12 centimeters. So we need to find the length of AC. It's a very simple solution. By Pythagoras theorem, AC square is equal to AB square plus BC square. AC square is equal to 5 square plus 12 square on plugging in the values from the given triangle. AC square is 25 plus 144, which is adding up to 169. And what's AC then? Nothing but just square root of 169, which is 13 units or 13 centimeters. Now, whenever we're learning something, we must think, what is its usage in real life? So where is this theorem applied in real life? It has a wide number of applications. Let us see. Have a look at the figure. Onesto is trapped at the rooftop of a burning building. In order to rescue him, his father Diego must find a ladder which will be used to cross the river and go up directly to the top of the building. Help Diego find the appropriate length of the ladder from the other side of the river to the top of the building. And I've already mentioned here that the length of the ladder is 25 feet. Think how. So the application of Pythagoras theorem extends to engineering, construction, measurements, and all geometry related fields. All these wonderful structures like the tallest tower in the world, the Burj Khalifa and the Golden Gate Bridge, etc. All these beautiful structures that we admire is possible because of the application of mathematics and geometry in construction. So it's really an interesting subject and has a wide variety of applications. Thank you so much.